Okay, so today I'd like to talk about two different things in regards to properties of exponents. The first one is I want to talk about zero as an exponent. Sounds very, very odd. Believe it or not, we can actually end up with an exponent of zero. And I've put in a box here the rule. I'm just going to give it to you right off the bat. Anything to the zero power is going to be 1. I'm going to take a moment to explain this to you, why this works. But anyway, this x represents anything. Anything, it can be a number, it can be a variable, it can even be an equation. If you take that all to the zero power, it is going to equal 1. So to explain this property, I'm going to begin with a problem. X to the third all divided by x to the third. Now if you remember the quotient rule actually tells us that what we can do is we can actually take the numerator, the exponent in the numerator, which is 3, and I can subtract it from the denominator. So I'm going to write from the exponent in the denominator. So I'm going to go ahead and write x to the third minus 3. 3 minus 3 is going to actually give us x to the 0 power. Now, there's another way that we can actually look at this, and what we can do is we can actually think about what this 3 actually means in the top. In the numerator, x to the third means that there's 3 x's. I'm going to go ahead and put 1, 2, 3 x's in the numerator. In the denominator, I'm going to go ahead and put 3 x's as well. 1, 2, 3. When I go about and I start canceling these off, if you take a look at this here, x divided by x is going to cancel. That's going to go away. X divided by x is going to cancel. That is going to go away. And one more pair of x's is going to cancel. And if you think about this here, I'm going to end up with the number 1. Thus, you can go ahead and tell me that anything to the 0 power is going to be 1. Okay, so after we've understood this, I just want to go through 3 separate examples. Take a look at each one of these. On this first example here, you'll notice that I have 3 to the 0 power. 3 to the 0 power is simply going to equal the number 1. When I take a look at the second example here, I have the quantity 4x all to the 0 power. Because that 0 power is being applied to everything inside those parentheses, that's also going to equal 1. And my third example here, I've got a huge coefficient on this, 15,684 x squared y to the third, all of that to the 0 power. That is also going to equal 1. Okay, so I've got 3 more examples here up on the board for you to take a look at when it comes to 0 as an exponent. We need to be very, very careful with this. Let's go ahead and take a look at the first example that I've got here. I have 5x to the 0 power. This 0 exponent is actually only on the x. It isn't on the 5. And so in essence, what this becomes is that x to the 0 power really basically becomes a 1. And so I can go ahead and basically cross it off, and because 5 times 1 is just going to simply give me 5. Be careful that 0 was not on the 5, so it did not affect it. When I take a look at the second example here, I have 2x squared y to the 0 z to the third. In this scenario, the 0 as an exponent, excuse me, I want to change my color here. My 0 as an exponent is actually only affecting the y. And so in essence, I can go ahead and cross it off. It becomes the number 1, and this is going to simplify to 2x squared z to the third. In essence, the y to the 0 goes away. My third example here on the bottom is a quotient where I have a b in the numerator that has a 0 power. So b to the 0 power there, in essence, gets canceled or crossed off. And c to the 0 in the denominator also gets crossed off. And what I'm left over with is I still have a quotient. So I'm going to go ahead and put my fraction bar down there. And I'm going to go ahead and write 4a squared. And I'm still going to have d to the 4th power down below. Hopefully this helps you out with 0 as an exponent. I'm going to go on right now to talk about negative exponents next. Okay, so now that we've got 0 down as an exponent, we want to discuss what happens when you have a negative exponent. I'm going to go ahead and just put the rule up here right off the bat. A negative exponent, anything to the nth power, so I've got x to the negative n power, is going to become the reciprocal. And so what I'm going to basically do is I'm going to flip this upside down. You'll notice this x was in the numerator and it gets flipped over and it becomes the reciprocal. So I want to take a moment just to kind of show you where this comes from by using the quotient rule, but I wanted to start by basically giving you the rule up front. Okay, so I want to explain this rule to you about negative exponents by looking at a quotient. Here I have x to the third power all divided by x to the fifth power. Now we can actually use the quotient rule on this to simply subtract. So if I take this, this is going to become x to the 3 minus 5 is what I'm going to have here. And if you do that here, if I take a look at that here, 3 minus 5 is going to give me x to the negative 2. So that is one way to be able to look at this, is actually using the quotient rule. Another way that we can look at this is we can simply just expand these. So let's go ahead and expand this out. In the numerator here, I've got x to the third power, which means that I have 3 x's. 1, 2, 3 x's. In the denominator, I have 5 x's. 1, 2, 3, 4, 5. If I take a look at this here, I'm going to go ahead and extend that bar here for a moment. There are a number of x's that are going to cancel. And so here I've got x over x. That cancels. X over x. That cancels. And x over x. That cancels. And when I simplify this, this is going to be 1 all over. How many x's do I have? I have x to the which power? X to the second power. Now hopefully you recognize this is as I go from here to here, these two are exactly the same. So you can see that negative exponent actually just takes the number, the negative 2, and puts it down into the denominator. It takes the reciprocal of it. I'm going to go ahead and do a few examples now. Okay, so I've got my first 3 examples here are kind of going to show you a couple of different scenarios that you can bump into, and then I'll do maybe 1 or 2 more complicated ones after this. Taking a look at this first example here, I have 4 to the negative 2. I tell my students anytime you see a negative exponent, go ahead and give yourself a fraction bar first. What I'm going to do is I'm going to move this 4 from the numerator down to the denominator, and then the 2 here, which was negative, is going to become positive. I've taken it and I've moved it down to the reciprocal. I must actually put the 1 in top here, and then I can simplify this as 4 squared is going to give me 16. Therefore, 4 to the negative 2 power is going to equal 1/16. The next example that I have here has got actually a coefficient of 3 in front. So this is going to be 3x to the negative 4th power. So once again, going along with those same safety things, where I say if you see a negative exponent, just go ahead and give yourself a fraction bar. When I take a look at my 3 here, there is nothing, no exponent affecting that, and thus that 3 can stay in the numerator. But this here does have a negative. That x to the negative 4 is going to have to go down below, and thus I'm going to go ahead and move x to the, and it's going to become positive 4. That's going to be my answer there. 3 all over x to the positive 4. The last one on this screen here that I'm going to do is I'm going to take a look at this here. This has got a negative coefficient in front of it. Be careful with that. That can be a tricky thing for people. That is just simply a negative number. It is not a negative exponent. So you want to go ahead and leave that negative 5 in the numerator where you found it before. But what I have here is I do have an a to the negative 2. That is going to go ahead and move down below, a to the positive 2. And then this b to the 4th is going to simply stay up top as well. There's going to be your answer on that one. So anyway, those are my first 3 examples here. I'm going to go forward and do 2 more for you. Okay, so 2 last quick examples. The first one up top here, I've got x squared all divided by y to the negative 3. So you may be wondering, well, what happens if the negative exponent is already in the denominator? Well, what we want to do is we actually want to just simply take the reciprocal of this. So I always tell my students, once again, if you have a negative exponent, go ahead and give yourself a fraction bar. It is a nice, safe thing to have. Nothing's going to hurt you with a fraction bar. I take a look at the x squared in the numerator, and I'm just going to go ahead and copy that down. There's nothing going on with that. But the y in the denominator has a negative 3. What I need to do is I need to take that and move it up top to make that exponent positive. So that is going to come up top, and it's going to become y to the positive 3. Now you'll notice that I've moved everything out of the denominator, so this fraction bar can simply continue on. It can just become the bottom of your box where you box your answer. So there's nothing wrong with actually having a fraction bar. Moving to my last example here to wrap up this video for you. Here I've got a fraction bar with negative exponents. Go ahead and give yourself a fraction bar for sure. I have two scenarios here. So the first scenario here is in the numerator, I have a to the negative fifth. This is going to actually move down below. So a to the negative fifth is going to become a to the positive fifth, like this. And then the b in the denominator is also negative. That's going to go ahead and move up top. In essence, what's going to happen with these two is that they are going to basically switch places. Anything with a negative exponent in the numerator is going to move to the denominator, and anything with a negative exponent in the denominator is going to move to the numerator. So anyway, that is your answer. Sorry for the long video. I probably should have made this in 2 videos, but I thought that these topics really, really do belong together, both 0 as an exponent and negative as an exponent. I hope you have a great day.